You're standing in a church, somewhere in Eastern Europe. Above you, in the bell tower, hangs a bell. Bronze, heavy, covered in verdigris and the dust of decades. You think you know what it is? A bell, simple, medieval, made to call people to prayer, to mark the hours, to warn of fire or invasion. Now forget everything you think you know about bells, because what if I told you that between 1922 and 1941, the Soviet government confiscated nearly every church bell in the territory it controlled? Not just a few, not the valuable ones. All of them, every single bell from Vladivostok to Minsk. They called it a campaign for non-ferrous metals. They said they needed bronze for industrialization. They melted most of them down. But here's what they don't tell you. The confiscation orders were too specific, too systematic, too coordinated across thousands of kilometers. And the bells they targeted first, the ones they documented most carefully before destruction, weren't the largest or the most valuable. They were the oldest. The ones with measurements that didn't match anything made after 1850. The ones that, when struck, produced frequencies that made no sense. This is the story of what the Soviet government found when they started measuring those bells, and what they destroyed to make sure no one else would ever find it. The archive room in the State Historical Museum smells like old paper and failure. I've been here before, digging through documents that probably shouldn't still exist. But this particular folder, catalog number 547 Clay 12, metal requisition orders, religious structures, 1922, 1923, this one felt different the moment I opened it. The folder contains requisition forms, standard bureaucratic documents listing churches, the number of bells to be confiscated, estimated weight, transportation instructions. Boring. Expected. Exactly what you'd find in any Soviet archive from this period. Except for one thing. Tucked between pages 47 and 48, there's a handwritten note. Not typed. Handwritten. On different paper. The ink is faded but legible. Izmerit chistatu, dezulat izyatia. Neobsujdat resulted is resulted. Measure frequency before confiscation. Do not discuss results. Why would you measure the frequency of a bell before taking it? If you're just melting it down for bronze, you don't care what note it plays. You care about weight, purity of metal, transportation logistics. You don't care about frequency. Unless frequency was the entire point. I spent 3 weeks going through every requisition order in that archive. Thousands of bells. And that phrase, measure frequency before confiscation, it appears in the orders for specific churches. Not all of them. Specific ones, always the oldest churches. The ones built before 1800, most before 1700, some dating back to the 1400s. And next to some of those orders, in the margins, written in pencil, numbers. 170.461, 204.553, 136.368. No context, no explanation, just numbers with 3 decimal places of precision. Those numbers haunted me, because when I finally figured out what they meant, when I understood what those Soviet bureaucrats had been measuring in 1923, everything changed. They weren't measuring musical notes, they were measuring something else. Something that bell makers in the 20th century had forgotten how to build. Something that the oldest bells, the ones forged in workshops that disappeared centuries ago, still carried in their bronze. The Church of the Resurrection stands on a hill overlooking the Volga, or it did. Now it's a museum of atheism, its frescoes whitewashed, its iconostasis removed, its bells long gone. But in the archive of the Kostroma Regional Museum, there's a photograph. The photograph is dated April 12, 1924. It shows 5 bells hanging in the church tower. The largest bell, the one in the center, is massive. The inscription on its surface is partially visible. 1647. The requisition order for this church is unusually detailed. It lists each bell separately. Weight, approximate age, condition. And for the bell dated 1647, there's an additional line. Frequency measured, 170.461 Hz. Consult Comrades Donov before removal. I found Comrades Donov's report, 3 archives later, in St. Petersburg, misfiled in a box labeled Industrial Equipment Surveys. The report is 8 pages long. Most of it is technical jargon about metal composition and acoustic properties. But on page 6, there's a paragraph that stopped me cold. The bell produces a fundamental frequency of 170.461 Hz with harmonic stability unprecedented in our measurements. The frequency does not waver. Standard temperature variations produce no detectable dry feed when struck. The bell maintains this frequency for 38 minutes. And 12 seconds before amplitude decay renders it unmeasurable. This degree of precision suggests manufacturing methods inconsistent with known 17th century capabilities. The bell's internal structure, examined via acoustic impedance mapping, reveals cavities and mass distribution that appear intentionally designed to produce this exact frequency. Purpose unknown. Recommend immediate study before any confiscation. 38 minutes and 12 seconds. Let that sink in. When you strike a bell, it rings. The sound decays quickly. A modern church bell rings for maybe 10-15 seconds before the sound fades below hearing. This bell rang audibly for nearly 40 minutes, and it held the same frequency the entire time. Exactly 170.461 Hz. Not 170.4, not 170.5, 170.461. That's not a bell. That's a frequency generator. The requisition order for the Church of the Resurrection was carried out on June 3, 1924. All 5 bells were removed. The large bell from 1647 was transported separately, under guard, to Moscow. The other 4 were melted down in Kostroma. The large bell was never seen again. Its fate is not mentioned in any subsequent document I could find, but that number, 170.461 Hz, it appears in documents from other churches, different cities, different years of construction, always on the oldest bells, always measured to 3 decimal places, always with the same impossible stability. The Peter and Paul Cathedral in Kazan had 9 bells. The oldest, cast in 1672, weighed approximately 3,200 kilograms. The requisition order is dated March 1925, and next to the entry for the 1672 bell, frequency 170.461 Hz. The same frequency, to 3 decimal places. From a bell cast 25 years later, 800 kilometers away, by different founders in a different workshop. You could call that coincidence, but I kept looking. The Assumption Cathedral in Nizhny Novgorod. Bell dated 1683, frequency 170.461 Hz. The Transfiguration Cathedral in Vyborg. Bell dated 1691, frequency 170.461 Hz. The Trinity Monastery in Pskov. Bell dated 1654, frequency 170.461 Hz. I found 12 churches with documented measurements before I stopped counting. 12 bells, cast across a span of 50 years, in workshops separated by thousands of kilometers, all producing the exact same frequency to 3 decimal places. That's not coincidence. That's coordination. That's standardization. That's evidence of a network. But a network of what? Bells are musical instruments. They're supposed to sound different. That's the entire point. A set of bells produces a range of notes. You don't want them all ringing at the same frequency. That's useless for music. Unless music wasn't the point. I started mapping the churches, plotting their locations on a map of Russia and Eastern Europe, and as I marked each church, with a bell documented at 170.461 Hz, a pattern emerged that made my hands shake. They formed a line. Not perfectly straight but close, from Pskov in the northwest, through Moscow, down to Kazan, continuing east toward the Urals. Roughly 2,000 kilometers, each church spaced approximately 200 kilometers from the next. Like relay stations, like nodes in a network, like a transmission system that stretched across a continent. I'm not an acoustics engineer, but I know people who are. I sent the measurements to a friend who designs concert halls, who understands how sound behaves, who spent his career thinking about frequency and resonance and wave propagation. His response arrived 3 days later. These numbers are impossible. Here's why. When you cast a bell, you're creating a resonant cavity. The frequency it produces depends on dozens of variables: the thickness of the metal, the shape of the dome, the mass distribution, the alloy composition, even the ambient temperature and humidity when it's cast. Modern bell foundries use computer modeling and can't achieve precision better than plus or minus 2 Hz, and that's with temperature-controlled environments and digital sensors. In the 17th century, bell founders worked by eye and by ear. They used hand tools and clay molds. Temperature control meant wait for a good day. They couldn't measure frequency to 3 decimal places because they didn't have the instruments. The concept of precise Hertz measurements didn't exist until the 19th century. And yet these bells, separated by hundreds of kilometers, cast decades apart by different craftsmen, all produced 170.461 Hz. Not 170, not 170, not 171. 170.461. My friend ran calculations. To achieve this level of precision, by accident, every variable in the casting process would need to be controlled to within tolerances of less than 0.1%. The bronze alloy would need to be identical to within parts per thousand. The cooling rate would need to match exactly. The final dimensions would need to be perfect within millimeters, even on bells weighing several tons. There's no way, he wrote, that 17th century founders could do this once, let alone multiple times across different workshops. Either your measurements are wrong, or these bells were built by people who understood acoustic resonance better than we do now. The measurements weren't wrong. I'd seen the original documents. 3 different Soviet engineers working independently in 192, 1925, all measured the same frequencies and recorded them with the same precision. Which means, the second option, people who understood acoustic resonance better than we do now. People who built a frequency network spanning thousands of kilometers, who knew exactly what frequency they needed, who built bells that could produce that frequency with impossible precision, who positioned those bells in a geometric pattern across Eastern Europe and Russia, and then someone, or something, erased every trace of what they were building. His name was Mikhail Korsakov. He was an acoustics engineer assigned to the State Commission for Confiscation of Non-Ferrous Metals. His job was simple: catalog bells, measure their composition, estimate melt weight. But Korsakov made a mistake. He got curious. I found his personal notebook in the Russian State Archive, misfiled under Industrial Surveys, 1926. The notebook is small, leather-bound, filled with careful handwriting and precise diagrams. Most entries are routine measurements. But starting on page 34, the tone changes. April 15, 1926, measured bell at St. Nicholas Cathedral. Date of casting, 1678, frequency 170.461 Hz. This is the 7th bell with this exact frequency. The probability of this occurring by chance is infinitesimal. There must be intent. There must be purpose. But what purpose requires a bell to ring at precisely this frequency for 38 minutes? May 3, 1926. I requested permission to delay confiscation of the St. Nicholas bell for extended study. Request denied. The bell will be removed tomorrow. Comrades Danov personally oversaw its transportation. I was not permitted to accompany it. When I asked where it was being taken, he said Moscow, for metallurgical analysis. But I have conducted metallurgical analysis. The bronze is unremarkable. The frequency is what's remarkable. And they're taking it before I can understand why. May 10, 1926. 6 more bells confiscated this week, all pre-1700. All measured at 170.461 Hz. All transported separately. I followed one of the trucks. It didn't go to any metallurgical facility. It went to a warehouse on the outskirts of the city, guarded by NKVD. I was turned away at gunpoint. The entries stop on May 18, 1926. The last entry reads, "I have been instructed to cease all frequency measurements. The Commission's work will continue without me. My equipment has been confiscated. My notes have been requested for review. I am writing this before I surrender them." If anyone finds this notebook, the bells were not bells. They were components in a system we do not understand. A system that someone desperately wants us to forget existed. Mikhail Korsakov's official record ends in June 1926. He was reassigned to a construction project in Siberia. There's no documentation of him after 1927. His notebook survived only because someone at the archive misfiled it, saving it from whatever purge claimed his other notes. But his question remained, written in careful script on page 47, what system requires precision frequency generators positioned every 200 kilometers across a continent? The Church of St. Prejesses or both? Page 47, Andrew stood on a hill overlooking the Dnieper River. Its bell tower contained 7 bells. The oldest, dated 1663, was removed on March 12, 1927. The requisition order contains the now familiar annotation, frequency, measured before confiscation. But this time, the number was different. Not 170.461 Hz, 204.553 Hz. I almost missed it. I'd become so focused on the 170.461 Hz frequency that I was scanning documents looking for that specific number. But this notation made me stop, because the same impossible precision was there, 3 decimal places. And when I went back through earlier documents, I found it. Different bells. Same pattern. The Cathedral of the Assumption in Lviv. Bell dated 1669. Frequency 204.553 Hz. The Trinity Church in Chernihiv. Bell dated 1675. Frequency 204.553 Hz. The Transfiguration Cathedral in Poltava. Bell dated 1682. Frequency 204.553 Hz. 2 frequencies, 2 networks, running parallel across Eastern Europe. I mapped them. The 170.461 Hz bells formed a line running roughly east-west. The 204.553 Hz bells formed a line running roughly north-south. And where they intersected in the region around Moscow, there were churches with both frequencies. Churches that had multiple bells, some at 170.46, 1 Hz, some at 204.553 Hz, carefully documented before their confiscation. The pattern was becoming clearer and more impossible. This wasn't just a single line of relay stations. This was a grid, a network of intersecting frequency lines covering thousands of square kilometers. But frequency networks need receivers. They need transmission. They need power. A bell doesn't broadcast. It rings. The sound travels maybe a few kilometers at most. Even with perfect frequency stability, a bell in Moscow can't communicate with a bell in Kazan 800 kilometers away, unless the sound wasn't the point, unless the frequency itself was creating something else. Some kind of resonance, some kind of field, something that could span distances that sound never could, something that required perfect precision across continental distances, something that the Soviet government in 1927 was systematically dismantling. It was 2 a.m. when I finally saw it, not in an archive. In my apartment, I'd covered my wall with maps, pins marking every church where these frequencies had been documented. Red pins for 170.461 Hz, blue pins for 204.553 Hz, lines drawn between them. The pattern was there, but it was more than just a grid. The spacing between churches wasn't random. It was consistent, 200 kilometers, sometimes 198, sometimes 203, but always close to 200. Like the network was designed with this specific distance in mind. I pulled out a calculator. 200 kilometers, 200,000 meters, and I thought about frequency. 170.461 Hz. That's cycles per second. Wavelength. Sound travels at about 340 meters per second in air, so the wavelength of a 170.461 Hz tone would be about 2 meters. That doesn't help. 2 meters is nothing. You can't build a communication network with a 2-meter wavelength and 200 kilometer spacing. The math doesn't work unless it's not traveling through air. Sound travels differently through different media. Through the earth itself, through bedrock, through stone, sound travels as seismic waves at speeds that vary depending on the material. But the earth's crust, dense rock, those speeds can reach 6,000 meters per second or more. I recalculated. If these frequencies were traveling through the earth, if these bells were somehow coupling their vibrations into the ground, into bedrock, then the wavelengths would be completely different. And I remembered something from physics. If you want to create a resonant system, if you want waves to reinforce each other rather than cancel out, you space your nodes at specific intervals related to the wavelength. I recalculated again, this time thinking about the Earth's structure, the crust, the mantle, the way seismic waves propagate through layers of different density, and I plugged in 174.61 Hz, not as the fundamental frequency, but as a harmonic. The math worked. If these bells were designed to create resonance in a geological structure, if they were positioned to set up standing waves in the bedrock, then spacing them roughly 200 kilometers apart would make sense. They would reinforce each other, each bell adding its vibration to a larger pattern, a continental scale resonance system. But why? What does a resonance network in bedrock do? What can you accomplish by setting the ground vibrating at precise frequencies across thousands of kilometers? I don't know. But someone knew. Someone built it. And in 1923, someone else started tearing it apart. Not every confiscated bell was melted down. Some were taken to laboratories, studied, dissected. And if you know where to look, you can find fragments of those studies still buried in Soviet archives. The Institute of Applied Acoustics in Riga received 3 bells in 1928. The director, Dr. Janis Lipa, was ordered to determine acoustic properties relevant to industrial applications. His reports are clinical, careful, deliberately boring. But between the lines, you can see his growing confusion. Report 3/5, 1928. Bell designated sample K1, dated 1671, weight 1,240 kilograms, struck with standard mallet. Frequency, produced. 170.461 Hz. Frequency stability, exceptional. No measurable drift over a 40-minute observation period, despite ambient temperature variation of 3 degrees Celsius. Further analysis reveals unusual internal structure. Standard bells are cast as single pieces, with relatively uniform wall thickness. Sample K1 exhibits precisely machined cavities within the bronze, creating a complex internal geometry. X-ray examination suggests these cavities form a 3-dimensional pattern, possibly designed to enhance specific vibrational modes while damping others. The precision required to create such structures with 17th century technology is unlikely. Report 3A, 5-2, dated July 8, 1928. conducted resonance coupling experiments, suspended sample K1 and sample K2, also rated 170.461 Hz, in same chamber, separated by 8 meters. Struck K1, K2 began resonating sympathetically within 12 seconds, eventually achieving 40% of K1's amplitude, despite no physical connection. When both bells were then struck simultaneously, observed unexpected acoustic phenomena. Formation of standing wave pattern in chamber air, with stable nodes and antinodes persistent for duration of ring. This suggests the bells were designed to work together, to couple, to create reinforcing patterns. Implications unclear. Dr. Lipa's reports continue through 1928, each one more puzzled than the last. His final report, dated November 23, 1928, is just 3 sentences, requested guidance on interpretation of results. Current findings inconsistent with accepted historical metallurgical capabilities, unable to determine practical applications that would justify observed design complexity. The Institute received no guidance. Instead, on December 1, 1928, Dr. Lipa received new orders: discontinue all research on confiscated bells, transfer all samples to Moscow, destroy all copies of reports. Dr. Lipa's personal archive, seized after his arrest in 1937, he died in prison in 1940, contains a single page of handwritten notes dated December 2, 1928. They do not want us to understand. That much is clear. But I understand enough. These are not bells. These are transducers. These are elements in a system designed to manipulate vibration at scales we cannot imagine. Someone built this system, and now someone is erasing it, and us along with it. Estonia's churches were smaller, less grand than their Russian counterparts, but they had bells, old bells. And when the confiscation orders reached Tallinn in 1929, they followed the same pattern. Document frequencies, remove oldest bells. First, transport separately. But in Tallinn, something different happened. Someone kept records that weren't supposed to survive. The Cathedral of St. Mary had 3 bells. The smallest, dated 1648, was measured at 170.461 Hz. Standard. Expected. But the requisition officer, a man named Anders Tam, added a note that appears nowhere else in any document I've found. Bell positioning 59.4370 degrees N, 24.7449 degrees E, elevation 34 meters above sea level. Distance to nearest confirmed 170.461 Hz. Source, Paskov. 267 kilometers bearing 127 degrees. Distance to next presumed source, Stockholm, unconfirmed. Approximately 357 degrees. Network terminus? Tam was mapping the grid, and he'd noticed something. The line of 170.461 Hz bells that ran east-west across Russia. It ended in Tallinn. There were no more churches to the west with documented measurements. The Baltic Sea interrupted the pattern, unless it continued underwater. Or the network had a different structure near its edges. Or Tallinn wasn't the edge at all. It was a terminus, a junction point where the system transitioned to something else. Tam's notes continue. Inquired about Swedish churches. Request denied. Informed that Swedish territory outside scope of confiscation program. But if network continues into Sweden, Norway, Finland, if these bells are nodes in continental system, then current confiscation program only capturing eastern portion, western portions remain intact. Operational? Anders Tam disappeared in 1930. His name appears on a list of counter-revolutionary elements, arrested in March of that year. No trial record. No prison, just arrested and gone. But his question remained. If the network continued west, if there were bells in Stockholm, Oslo, Copenhagen, producing the same impossible frequencies, then the Soviet confiscation program wasn't destroying the network, it was just claiming the eastern half. I started looking at churches in Sweden, in Norway, in Finland. The records are fragmentary. Church bells in Western Europe weren't confiscated en masse. They're still there, still hanging in towers, still ringing on Sundays. Still ringing on Sundays, but I found 3 references, just 3, in maintenance records from churches in Stockholm. 1672 bell, Trondheim, 1681 bell, and Turku, 1664 bell. Each record mentions acoustic testing conducted in the 1930s as part of structural surveys, and in each case, buried in technical appendices, a frequency measurement, 170.461 Hz. The network didn't end in Tallinn. It continued west, and those bells, the ones outside Soviet territory, they're still there, still hanging, still capable of resonating at frequencies chosen 3.5 centuries ago for reasons we've forgotten. Most confiscated bells were melted down, but not all. Some were transported to Moscow, stored, studied, and if you trace the paperwork carefully enough, you can figure out where they went. The Central Institute of Special Technologies. That's what it's called now. In 1930, it was called something else, Laboratory 47, under the direction of the NKVD's Scientific Research Directorate. The laboratory's official purpose was investigation of advanced materials for industrial application. Its actual purpose was more classified. I can't access the laboratory's records directly. They're still restricted, nearly a century later, but I found shipping manifests, transportation orders, and they all show the same pattern. Bells measured at 170.461 Hz or 204.553 Hz were not sent to foundries for melting. They were sent to Laboratory 47. Between 1924 and 1938, at least 47 bells were transported there. The last recorded shipment arrived on October 12, 1938. After that date, the laboratory's shipping records go blank. Not because the work stopped, because the documentation became too sensitive to preserve. But there's one document, one report that escaped classification because someone misfiled it. A requisition order for equipment, dated 1935, signed by the laboratory's director and sent to the State Planning Committee. The requisition lists high-precision oscillators, seismographic recording equipment, underground testing facility construction materials, electromagnetic field sensors, and transportation budget for field research to previously documented bell locations. They were testing them, installing equipment at the old church sites, measuring something in the ground, looking for whatever effect these bells were designed to create. And they found something. I know they found something, because in 1937, the laboratory's budget increased by 400%. The staff tripled, and starting in 1938, a new classification appears in Soviet budget documents, Project Resonance. No description, no details, just budget allocations. Huge budget allocations, continuing through 1941, then everything stops. June 1941, Germany invades, the Soviet Union goes to war, and Project Resonance disappears from all records. The laboratory is evacuated. The bells are moved to where no document says. After the war, Laboratory 47 reopens, but it's working on different things now. Nuclear research, rocket science. The bells are never mentioned again in any document I could find. But that equipment they requisitioned in 1935, seismographic recording equipment, electromagnetic field sensors, that tells you what they were looking for. They were measuring the Earth, looking for vibrations, looking for fields, looking for evidence that these bells, when activated, could create effects that propagated through rock, through soil, through the planetary crust itself, effects that could be measured hundreds of kilometers away, effects that could create standing wave patterns across continental scales, effects that would make no sense unless you understood that these bells were never meant to be musical instruments. They were components in a geophysical technology we no longer understand. His name was Stepan Volkov, and he was 76 years old when they interviewed him. He'd spent his entire life casting bells, learning the trade from his father, who'd learned it from his father, stretching back generations to before anyone kept written records. The interview transcript is buried in a folder marked Folkcraft Documentation. 1932. The interviewer was interested in casting techniques, in the folklore of bell making. Volkov told him something else. Interviewer: and how did your grandfather determine the correct tone for each bell? Volkov: by ear, mostly, but not always. The old bells, the ones made before the French came, those followed different rules. Interviewer: what rules? Volkov: there were numbers passed down, never written. My grandfather knew them. The numbers told you the weight, the shape, the thickness of the bronze. Follow the numbers exactly, and the bell would sing at the correct voice. Interviewer: the correct voice? Volkov: the voice that matches the earth. That's what my grandfather said. The bells must speak to the stone, not to the sky. I didn't understand. I still don't. But I remember the numbers. For a bell to speak to stone, it must weigh 1,240 kilograms with bronze that is 78 parts, copper to 22 parts tin. The dome must be 2.73 meters from crown to lip. Follow these numbers, strike the bell, and it will hold one voice for as long as a man can pray the full rosary. Interviewer: what voice? Volkov: I don't know the name. My grandfather called it the first voice of the earth. He said there were 7 voices, but the foundries only remembered how to cast 3 of them. The first voice, the 4th voice, and the 6th voice. The others were lost, or forbidden. He never said which. Stepan Volkov died in 1934. His workshop had been dismantled in 1930. None of his bells survived. The knowledge he carried The numbers his grandfather taught him died with him, unless other founders knew the same numbers, unless this knowledge was widespread once, before the confiscations, before people learned not to speak about what the old bells could do. But Volkov's testimony confirms what the measurements showed. These bells weren't random, they were built to exact specifications. Specifications passed down through generations of founders who may not have fully understood what they were building, but knew the numbers had to be perfect, building to someone else's design, following instructions inherited from a time when people understood what these frequencies could do. I plotted every church I could find with documented frequency measurements. Every city, every village, every documented bell site across Russia, Ukraine, Belarus, the Baltic states. 127 locations with confirmed measurements. Dozens more with fragmentary records. The map covered my entire wall. Red pins for 170.461 Hz. Blue pins for 204.553 Hz. A few green pins for a third frequency I'd found mentioned rarely, 136.368 Hz. And when I connected them, when I drew lines between points with the same frequency, the pattern was undeniable. Not just lines. Geometries. Triangulations. The 170.461 Hz bells formed a grid running roughly east-west. The 204.553 Hz bells formed a grid running north-south. Where they intersected, there were often bells of both frequencies in the same town, sometimes in the same church. But it was more complex than that. Some cities had 3 frequencies. Some had bells positioned in specific triangular arrangements around a central point. And when I measured the distances between bells, they weren't arbitrary. They clustered around specific values. 200 kilometers, 173 kilometers, 141 kilometers. These are the distances you'd use if you were building a resonant grid. If you wanted to create constructive interference. If you were treating the Earth itself as a resonant cavity and positioning your sources to create standing wave patterns. I sent the map to my acoustics engineer friend. His response was brief. This is insane. If this is real, if someone actually built this, they understood wave mechanics at a level we barely reached in the 1960s. This is phased array technology. This is what we use for ground-penetrating radar, for seismic surveying, for detecting underground nuclear tests. But this was built in the 1600s. I looked at phased array technology. I read papers on seismic tomography. I studied how modern geophysicists map the Earth's interior using waves from earthquakes or controlled explosions. And I realized that's what this was. Not communication, not power generation. Mapping. This was a system for mapping the Earth's interior, for sending vibrations into the ground at precisely controlled frequencies and measuring how they reflected, refracted, changed as they traveled through different layers of rock. A continental-scale ground-penetrating radar system, built with bronze bells, positioned across thousands of kilometers, operated by people who rang bells not for prayer but for data, who listened not for music but for echoes in stone. Why would you need to map the Earth's interior in the 1600s? What were they looking for? What did they need to know? I don't have answers. But someone wanted to know badly enough to build this, and in 1923, someone else wanted to make sure no one ever used it again. The Church of the Savior on Naroditsa Hill is one of the oldest in Russia, dating to 1198. Its bell tower held 4 bells. The largest was so old, its date of casting had been worn away by centuries of weather. But examination of the bronze suggested it predated the church itself, possibly cast in the 11th century. The confiscation order for this church is dated May 1935, 12 years after the campaign began. Most bells had already been taken. Why come back to this remote church so late in the program? Because someone reported an anomaly. A local party official, conducting routine anti-religious surveys, had noticed something odd. On certain days, at certain times, the old bell would begin ringing on its own, without human touch, without wind strong enough to move it. Just ringing, briefly. A few strikes, then silence. The NKVD investigated. What they found is documented in a report I discovered in the Novgorod Regional Archive, misfiled in a folder about geological surveys. The report confirms the bell occasionally rang spontaneously. The investigators observed this firsthand. On May 17, 1935, at approximately 3:47 p.m., the bell struck 7 times. No one was in the tower, no wind, no apparent cause. Seismographic equipment was installed, and the investigators discovered something. The bell rang when seismic activity occurred elsewhere, small earthquakes, tremors, anything that sent vibrations through the bedrock. The bell was picking up ground motion and resonating, but not just any ground motion. The seismograph showed tremors at various frequencies throughout the observation period. The bell only responded to vibrations near 170.46, 1 Hz. It was functioning as a highly selective seismic detector, a filter that would ring only when the Earth vibrated at one specific frequency. The report's conclusion is brief. Bell removed June 3, 1935. Transported to Laboratory 47 for analysis. The bell arrived at Laboratory 47 on June 8. What they learned from it isn't documented in any file I could access. But I found something else. A geological survey map from 1936, covering the region around Novgorod, and someone, presumably one of the scientists at Laboratory 47, had marked locations on the map. Each mark corresponded to an old church site, and each church site was connected by hand-drawn lines. The lines weren't random. They outlined geological structures, fault lines, rock formations, underground voids, things that would affect how seismic waves propagated, things that would create reflections and refractions and vibrations traveling through the ground. Someone at Laboratory 47 was using the bell locations to map geology. They'd realized what I'd realized. These bells weren't just generating frequencies, they were positioned to detect them. They were both transmitters and receivers in a system that used the Earth itself as a medium. A system that could, in theory, map every geological structure across the continent. Find every fault line, every mineral deposit, every underground cavity. All you'd need was enough bells, properly positioned, resonating at known frequencies. Strike them in sequence, listen for the echoes, measure the timing, calculate the structure of everything beneath your feet. In the 1600s, they built this. In 1935, the Soviets were trying to understand it. By 1937, all research documents were classified, and by 1941, everything disappeared into the chaos of war. Last October, I went to Pskov. The Trinity Cathedral still stands. Its bells are long gone. The tower is empty, but I wanted to see it. Wanted to stand where the old bell had hung. Wanted to know if anything remained. I brought equipment. Not much. A sensitive microphone, a frequency analyzer, a seismograph cobbled together from off-the-shelf parts. I set it up in the cathedral square. And I waited. For 2 days, nothing. Just traffic noise, wind, pigeons, the background acoustic soup of a modern city. I was beginning to feel foolish. Chasing ghosts, hunting for vibrations that existed 90 years ago if they existed at all. Then, on the third day, at 4:23 a.m., my equipment woke me. The seismograph was recording. Not an earthquake. Something else. A persistent vibration. Low frequency. Steady. I checked the analyzer. 170.4 Hz. Not exactly 170.461. Close. Closer than coincidence should allow. The vibration lasted 47 seconds, then stopped. I waited. At 4:51 a.m. it happened again. Same frequency, 41 seconds this time. Then, nothing for hours. I don't know what caused it. Probably something prosaic. Underground machinery, water pumps, electric motors. There are 1,000 sources of low-frequency vibration in a city, but the frequency, 170.4 Hz. Almost exactly what those bells were tuned to. As if something in the bedrock remembers. As if the geology that was once resonating with bronze bells is still capable of vibrating at that same frequency. All it needs is a trigger, a push. And for a few dozen seconds, the network or some ghost of it wakes up. I took readings for a week. The vibrations appeared irregularly, sometimes once per day, sometimes not for 2 days. When they did appear, they were always near 170.4 Hz. Always lasting between 30 and 60 seconds, always strongest in the early morning hours. I filed a request to access the cathedral tower, to install equipment where the bells once hung. Request denied. Historical preservation concerns. I filed again, explaining I would cause no damage. Denied again. No explanation. I tried bribing the caretaker. He refused. People have tried before, he said, to measure things in the tower. They're always refused. There's a list. People who aren't allowed. I don't keep it. It comes from somewhere else. Moscow, maybe. But you're probably on it now. I left Pskov with more questions than answers. But I had my recordings. Proof that something is still there, still vibrating, still resonating at frequencies chosen centuries ago for purposes we've forgotten. The Central State Archive of Scientific, Technical Documentation in Moscow had a fire in 1997. Accidental, according to reports. Electrical fault. The fire destroyed approximately 40% of the archive's holdings, including, conveniently, almost everything related to the Bell confiscation program and Laboratory 47. Almost everything. One box survived. Only one. inside random documents that had been misfiled or miscategorized, including a 4-page memo dated February 8, 1936, from the director of Laboratory 47 to the head of the NKVD's Scientific Research Directorate. The memo's subject line, Project Resonance, Preliminary Conclusions and Resource Requirements. I'm going to quote from it. Analysis of confiscated samples confirms original hypothesis. The Bell network was designed to create standing wave patterns in crustal rock formations across continental scales. Mathematical modeling suggests optimal network would require minimum 300 nodes spaced at intervals of 173,200 kilometers, with each node producing one of 7 discrete frequencies. Current confiscation program has secured approximately 189 bells meeting technical specifications, representing approximately 63% of estimated network. Experimental activation of secured samples in controlled underground facility demonstrates proof of concept. Simultaneous activation of 3 bells at 170.461 Hz produces measurable seismic vibrations propagating through bedrock with coherent phase relationships at distances exceeding 2 kilometers, affect scales with number of sources. Extrapolation suggests full network of 300+ bells could generate detectable signals across distances exceeding 1,000 kilometers. Primary questions remain. What information did original network operators extract from received signals? What geological features were they mapping? Why construct this system at continental scale? Recommend continue confiscation of remaining bell samples, expand underground testing facility, initiate geological surveys at documented bell sites, consider potential military applications of verified acoustic resonance technology. The memo confirms everything I'd pieced together from fragments and hints. They knew. The Soviets knew exactly what they'd found. They understood that this was a seismic mapping system. They were actively trying to recreate it. They saw military applications, strategic advantages. They were going to rebuild the network underground, in secret, under their own control. And then, the memo is from February 1936. The program was allocated massive resources through 1941. Then everything vanishes in the war. I found no documents after 1941, no evidence the project continued. The trail goes cold in the chaos of World War II. But that memo, that one surviving document, it proves they understood. It proves the network was real. It proves the Soviet government believed in it enough to invest enormous resources in trying to understand and recreate it. After the war, the Soviet Union entered a new phase: reconstruction, modernization, and a systematic erasure of anything that didn't fit the narrative. Churches that had survived the Bell confiscations were demolished. Not all of them, but many. Especially the old ones. Especially the ones that had housed bells with documented frequency measurements. The demolition orders are standardized. Building structurally unsound. Demolition ordered for public safety. Over and over. Same language for churches that had stood for 500, 600, 700 years, but the demolition protocols were unusual. I found the specifications in a construction ministry archive. For churches designated Category K, special procedures were required. Remove all bell tower structures first. Break bell tower foundations to depth of 3 meters below grade. Fill excavations with concrete. Document precise coordinates of all bell suspension points before demolition. Why? If you're tearing down an old building, you don't need to know where the bells hung. You don't need to break the foundations extra deep and fill them with concrete unless you're trying to erase something. Unless you're trying to make sure that specific locations, the exact points where bells once hung, can never function as nodes in that frequency network again. Between 1945 and 1960, at least 83 churches with documented frequency measurements were demolished under these special protocols. Their bell towers were obliterated, their foundations were broken and filled, the sites were paved over. But not all. Some survived. Remote churches that were architecturally significant enough to protect. Their bells were gone, but the towers remained. The suspension points remained. The geometry remained. And in those places, in Peskov, in Novgorod, in a dozen other cities, you can still detect it. Those faint vibrations at 170.4 Hz, the ghost of a network that someone tried very hard to silence forever. Why build this? I've spent 2 years chasing this network, mapping it, documenting it, understanding how it worked, but I still don't know why it existed. A continental-scale seismic mapping system in the 1600s. Why? What did they need to know? What were they looking for? Natural resources? Maybe. If you could map underground structures, you could find mineral deposits. Coal, iron, gold. That's valuable. That could justify the enormous effort. But then why hide it? Why let the knowledge fade? Why not document it, preserve it, pass it down. Water? Underground aquifers. Knowing where water flows beneath the surface would be incredibly valuable. But the network wasn't concentrated in arid regions. It was spread across all terrain types, as if they were mapping everything. Earthquakes, fault lines. If you could map geological stress, predict where earthquakes might occur, that would save lives. But again, why let it fade? Something else? Something we're not thinking of? Some property of the earth that we don't even have a name for? Something that was important in the 1600s, but became irrelevant later? I don't know. And the not knowing haunts me, because this wasn't a small project. This was generations of effort, hundreds of bells cast to impossible precision, positioned across thousands of kilometers, maintained for decades, maybe centuries. You don't build something like this casually. You build it because you need it, because something requires continental-scale geophysical mapping, because something is important enough to justify the cost. What was it? Not every church was demolished. Not every bell was melted. Fragments remain. In the Museum of Russian History in Moscow, there's a bell. Small, maybe 40 kilograms. No label says where it came from, but the casting date is visible. 1669. I visited the museum last year. I brought a tuning fork, 170.461 Hz. I struck the bell gently when the guard wasn't looking. It resonated. Clear, perfect. The tuning fork and the bell sang together. They put it in a museum because it's old. They have no idea what it is, what it was designed to do. It sits on a shelf next to medieval pottery and antique clocks, labeled liturgical bell, 17th century. In Stockholm, the Storkyrkan Cathedral still has its original bells. One dated 1672, the church offers tours. They'll let you up into the bell tower if you ask. I asked. And when the tour guide wasn't paying attention, I used a frequency analyzer. 170.46. 1 Hz. Still there. Still perfect. Still hanging in its tower, ringing every Sunday, doing what it was designed to do, except no one's listening for the echoes anymore. No one's recording how the ground responds. No one remembers it's part of a network. These fragments exist, physical evidence that this network was real, but they're scattered, disconnected. Individual pieces of a puzzle that no one's trying to assemble anymore, because most people don't know there's a puzzle, except us, the people who've noticed, who've looked at the old bells and wondered why they're so precise, who've read the Soviet requisition orders and noticed the patterns, who've measured the distances and seen the geometry. We know there's something here, something real, something that worked, something that someone desperately wanted us to forget. Old churches, pre-1800. The older, the better. Churches that still have their original bells, or at least their original bells, towers. If you have access to frequency analysis measure them. If a bell produces a tone at 170.46, 1 Hz, 204.553 Hz, or 136.368 Hz, if it holds that tone for more than 30 seconds, if the frequency is stable, you've found a node in the network. Document the coordinates. Document the frequency. Document how long the tone persists. If you're in Russia, Eastern Europe, the Baltics, Scandinavia, look for demolished churches. Look for sites where old bell towers once stood. If you have seismographic equipment, set it up there. Wait, listen. You might detect residual vibrations, faint, irregular, but present. If you find something, be careful what you do with the information. The Soviet archives are still classified for a reason. Someone still considers this sensitive. I'm writing this because the knowledge shouldn't die. Because if enough people look, if enough people measure and document and share, then maybe we can reconstruct what was lost. Maybe we can understand what those builders knew. Or maybe we'll learn why someone wanted us to forget. I don't know which, but the questions are worth asking. The bells are worth finding. The frequencies are worth measuring. The earth is still singing, quietly, in frequencies we've forgotten to listen for. But the song persists, waiting for someone to remember how to hear it. The Church of the Resurrection in Kostroma is closed now, locked. A sign on the door says, "Under renovation, entry prohibited." The sign is dated 2018. I checked with the local authorities. No renovation is scheduled. No funding has been allocated. The building just sits there, locked and silent on its hill, overlooking the Volga. The bell tower is empty, but sometimes, locals say, on very quiet nights, you can hear ringing. Faint, brief, like an echo of something that used to be there, or something that's still there, waiting. I stood outside that church for 3 hours one night, listening. My equipment ready. My recorder running. I didn't hear anything, but maybe I wasn't listening right. Maybe the frequency is there, too low or too faint for ears and microphones. Maybe it's there in the stone itself, in the bedrock, in the deep earth. Maybe the bells weren't creating anything. Maybe they were just showing us what was already there, teaching us to hear what the earth has been saying all along. I don't know, but I'm still listening, still looking, still trying to understand what we lost when we lost those bells, because somewhere someone knows, someone understood, someone learned what the network was for, what it revealed, why it mattered. And maybe, if we're patient enough, if we're careful enough, maybe we'll learn it too. Until then, the frequencies echo. The bells are silent, and the earth keeps singing to anyone who remembers to listen.